We have previously restored two IBMs from the PC series, the 330 and the 350, but they actually don't look anything like the 300GL on the bench today. In fact, this IBM seems to have been designed by the same guys who designed the Aptiva we restored last week. I actually had one of these back in the late 90s. In this video we are going to do a complete teardown of this machine. The G74 display that came with the barn find Aptiva last week turned out to be broken, so I guess we'll try to fix it today too. This machine is unrestored but tested, and it doesn't seem to need much restoration. It's a bit dusty, but I'll quickly wipe that off camera. Unlike the Aptiva, these machines are made for business use. The Aptiva has a design for Windows 98 sticker, but this machine is designed for Windows NT or Windows 98. The cool thing about this series of IBMs is the design. It's quite different from other PCs, and it looks extremely 1990s, with this fake grill thingy going on here. It's a bit of an odd mix of square and rounded shapes. The 300GL name here doesn't really tell us much about this machine, because these IBMs were manufactured for so many years. I think they first came out with a Pentium 133 MMX, and the last one I think came with a Pentium III 866. That is a huge span of CPUs. This one clearly came with a Pentium III, so pretty late machine. Since it has the custom CD-ROM bezel, this machine was probably sold with a CD-ROM drive. But definitely not this one, so this must be an upgrade. I'll see if I can find a more suitable drive and we'll replace it. Down in the corner here we also have a sticker that tells us this is a type 6275. To get the lid off, we need to pull on these tabs at the back. Then we can just remove that lid. Inside here we've got our first dates, week 17 of 1999. The Plextor drive is indeed an upgrade, from July of 2001. At the back here we have one parallel port, two serial ports, built-in VGA, two PS2 connectors, and two USB ports. This machine also has two cards installed, so let's start by pulling those cards out. They were held in place with a custom bracket. So the first card is clearly a network card. This is just a regular 3COM card. Quite possibly the original card, because this machine has an extra LED on the front panel for network activity. So I'll keep this card with the machine. This card is a CT4810, so nothing special. The riser has two ISA slots and three PCI slots. Strangely enough, the side panel on the chassis here looks removable. So let's remove it. Yeah, that panel is definitely just installed with two screws. That's a bit unusual. There's also a lever here, so something is definitely going on here. I guess we should try to pull it and see what happens. Well, nothing much, apparently. Yeah, there's definitely some kind of quick release system going on here, but I'm not sure how it works, so I'll just use some more force, and hopefully nothing will break. I checked on Google, but the service manual I found didn't mention the motherboard, so I'm left with guessing here. I think I'm gonna remove the diskette drive to get better access to the motherboard. And I just noticed it's not correctly installed. So someone has been messing around inside this machine. It is installed at an angle. It's supposed to latch into this hook here, but it's not. But that's an easy fix. And now I can pry from the back here at the same time as I pull this lever. Let's see if this works. Well, that thing is pretty badly stuck in here. Well, I can't see any screws that would lock the motherboard in. And the I/O shield at the back here looks like it would slide out too. Same thing underneath the machine here. I can't see any screws that will lock the motherboard. Well, I pulled a little harder on this lever here, and something released. Yeah, it's sort of moving, but it seems to be stuck in something. Well, I guess I could remove the CPU to get better access with the prying tool. This guy here is a 450 MHz Pentium III with 512K of cache. It also has IBM part numbers, so probably the original CPU. Okay, let's try again. I'll pry some more from the back. Now this thing is pretty stuck. Okay, I think I got lucky. I pulled on this tab here and something released. So let's try again. Yep, that apparently was the trick. Now the entire motherboard just slides out on some plastic rails. So by pulling on this tab here, I released this peg here. Very service-friendly machine. So what have we got here? Well, these pads here look like they are for audio connectors. So some of these pads are probably for optional built-in audio. And these guys up here are probably for a built-in modem. And these pads here I think are for a built-in network card. On this side of the board we have the chip for the built-in graphics. We also have some extra VRAM here. 2 megs. And I can see some more VRAM chips underneath. So probably 4 megs of VRAM. So definitely good enough for some DOS adventure games. Let's get the drive out next and see if I can find a more suitable replacement for it. So the entire drive cage seems to be locked with these 2 screws. And then it's hinged. Actually, one of the screws here is missing. And under here we also have a hard drive. So the way it's designed, this screw here and another screw on this side here should be left in. And I think the entire drive cage should be flipped up. But since one of the screws is missing, I'm just going to remove the entire drive cage. This machine is unusually clean inside too. It's very nice for a change, not having to wash stuff. The hard drive is installed with screws that you would typically find in a compact. So I definitely think someone has been messing around in here. This drive is probably snatched from a compact. And it's a good old Seagate Barracuda 40 gig drive. I actually never had one of these fail on me. So this drive is probably working too. It has a rather strange date code, so I can't say for sure, but I think it's from 2003. One of the screws on the CD-ROM drive is missing too, so the previous owner seems to have been in a hurry when replacing this drive and upgrading that hard drive. These are also not your typical IBM screws, so they are missing too. This drive is really heavy compared to other drives, and it has a fan installed at the back. Never seen that before. I rather like this drive, so I'm going to install it in a period correct build. And in here we've got some weird and wonderful IBM stuff. So you may have noticed that the connector for the diskette drive and hard drive were not on the motherboard. Instead, they are on the riser here. It also has some additional power connectors. The fan, the speaker and the LEDs on the front panel are connected with this connector here. The power supply has all the usual connectors, and enough of them to make this machine useful, but the main power cable is very short and connected to the riser instead of the motherboard. So pretty unusual design. Well, we've had some issues with power supplies in slightly older IBMs, but let's hope this one is good. By the way, it's AC Bell branded. By the way, the cable management is really nicely done in this machine, but unfortunately someone crushed this cable when installing the power supply. So let's get inside the power supply next. And my usual disclaimer, please don't mess around inside power supplies or CRT displays. Some of the caps inside here could be charged with mains voltage, even with the cord unplugged. And there's an odd sticker here that says fitted by FCI. So who the heck is FCI? Never seen one of those stickers before. So could that be like a repair center? I guess I should do a quick Google. Well, I found something called IBM FCI, but that's probably not who installed this power supply. And apparently some more screws on the side. Okay, let's pry that lid off and see what we will find inside. Wow, this machine really is clean. So same thing inside here. I used to repair compacts in the early 2000s. So I have been inside many PCs. And I can tell you right away, this machine hasn't seen much use. There is hardly any dust inside here, even the fan is clean. So that's kind of strange that 2 of the drives were replaced on this IBM. And by the looks of it in a hurry, I guess someone with bad luck owned this IBM. None of the caps are bulging or showing any signs of leakage. There's a huge safety cap up here, but that is not a Rifa, that is some other brand. So this power supply should be safe to use. Well, now I'm curious, so let's remove that front panel with the fan assembly. Yeah, this fan tells the same story. It's perfectly clean. Can't see a speck of dust. So, someone bought this machine back in 1999 and forgot to use it. Well, I'm not gonna complain. Well, since we have removed everything except for the riser, we might as well remove it too and take a look. So it's locked with one screw and then installed on hooks. So this must be the most advanced riser I have seen so far, except for the obvious stuff here. We've got pin headers for SCSI LED, CD audio down here. This one is marked RFID, LAN wake, modem wake, one connector for a fan, and one connector marked alert. I'm not going to bother trying to find a matching drive. Instead I'm going to keep this Seagate Barracuda, but I did manage to find some original IBM screws. And I found a perfect match for this machine. It's a lucky gold star with IBM part numbers, and it's manufactured in 1999. This drive is not tested, so let's hope it works. Our luck continues. I found some original IBM screws for this drive too. I just noticed something here. The cage actually has some optional holes on the side here that are designed to be used with rubber grommets. These are pretty common in standard cases, but I have never seen it in an IBM before. So let's see if some standard rubber grommets will fit. So let's try these. These are leftovers from some other build. I don't remember which case. Yeah, I think they fit. It's a bit of a squeeze, but it's definitely worth a try. I also found some of the matching screws. I think this is going to work. With the hard drive installed, with these rubber grommets, it's going to make a lot less noise. Yeah, this is totally working. So these must have been standardized as early as 1999. To install the motherboard, I just have to align these rails with the correct set of tabs in the chassis here. Since IBM used this case for so many years, there must have been a lot of different motherboards for these machines. Well, it took some fiddling to install the board, but now it's back in the machine. Let's test this board with the original CPU first. All 4 screws on the diskette drive are loose. And this drive too has one of those weird stickers fitted by FCI. Never seen it before, not twice in the same machine. I'm of course going to make sure that the drive aligns with this hook here and gets correctly installed. Okay, time for a test. Let's see if this IBM still works. Looks kind of weird with that side panel off. Okay, posts. Let's jump into BIOS and have a look. Okay, this looks very familiar from other IBM systems. So we've got a Pentium III 450, 512 KB level 2 cache, and 768 megs of RAM. That's a big chunk of RAM for a Pentium III machine. And then we've got the onboard graphics, diskette drive, and even on time and date is not too far off. So the BIOS battery seems okay too. So everything in here looks okay. Let's see if it will boot. Okay, so we've got Windows XP on this machine. That's a bit too much for Pentium III 450, but it should work reasonably well. This copy of Windows must be activated with Microsoft before you can log on. Okay, well, I'm not going to keep this installation anyways. Let's test that diskette drive next. It seeks, and it reads, and it boots. So how about that CD-ROM drive? Let's restart the machine and see if it will boot from the CD-ROM. It does. Awesome. Well, I need an OS on that hard drive, so I'll install Windows 98 off camera here. The hard drive has an NTFS partition. So let's go to delete, non-DOS partition. I'm going to create one new primary partition. Okay, let's take care of the display next. So we restored this display together with an Aptiva last week. But unfortunately, this display turned out to be broken. When we turned it on, we could hear some high voltage. But then it made a very strange crackling noise. And it started to smell ozone in the studio. So let's see if we can fix it. And the reason why I include it in this video is because I think this G74 was most likely an option not only for the Aptiva, but also for the 300GL on the bench. Well, the studio now smells like ozone. To produce ozone, roughly 1000 volts is required. So unfortunately, I think we have some arcing going on inside here. I know that the display has been freshly turned on. I'm gonna have to be even more careful. Good CRT displays discharge when you turn them off, but I'm not going to bet my life on it. Okay, no sparks, so it has discharged. Well, I can't see any signs of arcing, and I deliberately didn't clean this area here, because the sticky stuff you see here is the electric grease. Same thing with the anode cap. I didn't wash it, because I don't have fresh grease to apply. So maybe that was a mistake. I should have ordered some. But there is quite a lot of that stuff left. I will of course order some. I should have done that a long time ago, since I'm restoring these CRT displays quite frequently. But my best bet for now is to just smear that stuff. And hopefully it will insulate well enough until I have received some dielectric grease in the mail. It is really sticky, so there's quite a lot of it left. Well, lesson learned. Okay, display reconnected. So let's turn the PC on first. Okay, fingers crossed. 3, 2, 1. Yeah, that definitely sounds like arcing, but I can't see anything. What is going on with this display? The LED on the front panel is flashing, so that indicates standby mode. And I have no image on the display. Let me try that power switch. No, it's doing nothing. Oh crap. No, I think there is something really messed up with this display. And I can smell ozone. But why aren't we seeing any arcing? This sucks. I hate this type of faults. I'm not getting any clues. Yeah, I'm not sure if the microphone picks this up, but every time I boot, I clearly hear some arcing. I can't see the damn thing. I guess I'll turn the lights off. We'll try again. Okay, I hope that's dark enough. 3, 2, 1. Yeah, that definitely sounds like arcing. I can't see anything. Man, this sucks. Okay, let's check the other side too. Man, it smells so much ozone in here now. So this is definitely an arcing issue. Oh, I saw it. It's on the neck board. I think it's on one of the caps. How weird is this? Okay, I moved in closer with the camera. This could be hard to see because I had to turn the lights off for you to see this. Now check this area here. 3, 2, 1. It's barely visible. Not sure if the camera picked it up. But there is some arcing going on here. I think on this cap here. This is a faulty display for sure. Well, it's hard to tell exactly, because I could only see it in the dark. But I'm pretty sure it came from this area here. Either on one of these components, or possibly in this gap here. So let's remove this shield here and take a look inside. Okay, let's remove that can. Yeah, see if we can get any clues. No, I don't see any burn marks in here either. Okay, let's make another test with a shield removed. Perhaps we'll see something on this side. Okay, 3, 2, 1. Still that sparkling sound, but I can't see anything glowing on this side of the board. The neck is not glowing, so the heater is not working. I can smell ozone again. So let's check this side of the board again. Yeah, I can clearly see some arcing. And then it went away. So next I'm going to push this cap to one side and check the component behind it. Sorry if this is hard to see, but I need to keep the lights off. Otherwise I can't see the arcing. Okay, it's not the cap. It is the component behind it. Okay, at least we know where the fault is showing up, but we don't know what's causing it. Okay, let's start by checking if we have a good ground connection on the neck board. We'll just measure the ground pin to the chassis. We are getting a lot less than 1 ohm. So we have good ground connection on the neck board. Okay, in that case, let's make sure we have a good connection between the neck and the neck board. I'll place a few drops of the oxide on every connector, at the other end too, of course. Then I'm going to disconnect and reconnect the board a few times because from experience adding deoxit isn't always enough. You may need to sort of scrape any corrosion off. Okay, I'll turn the lights off again and pay attention to this component here behind the cap. Okay, 3, 2, 1. Well, it's not glowing, but we still have that weird noise. And the tube is not glowing, so the heater is not turned on. Let me try the power switch on the front now. Okay, we've got high voltage. Same sparkling noise. Let me turn the machine on. Okay, we have some high voltage noise again. But the heater is not working. And the LED on the front of the display is flashing. So I think the display is turning itself off. Okay, in that case I'm going to mark every solder joint on this board, just to make sure I don't miss one. Then I'm going to reflow every single solder joint on this board. That paint is burning off, so this way I can be sure that I don't miss one. Okay, all the solder joints are nice and shiny. I'll just quickly clean this mess up. Okay, that's clean enough. Let's do another test. Okay, here goes. Still that same sparkling noise. I'll push the switch on the front. And that gave me that same sparkling noise. Crap, so it wasn't a bad solder joint. Okay, I managed to identify the component that lit up earlier. And this is a gas discharge tube. And it's designed to protect the tube from overvoltage. So something is really messed up on this PCB, and it seems to create an overvoltage. So this is no easy fix. Okay, maybe we're lucky here. I found what looks to be a trash-picked donor here in a really rough condition. So let's see if it works. I heard some relays when I turned the power on. Okay, we're getting high voltage. Let's turn that Aptiva on. Yeah, this one is working. Okay, so we've got parts. Awesome. Holy smokes. This one's really messed up. This is by far the worst tube I have ever seen. Holy crap. You can't even see that this wire is supposed to be red. And this thing still works. Unbelievable. This thing is just absolutely crazy. Yeah, there's your red wire. The camera isn't very good at capturing this. But everywhere we have high voltage in this display, everything is just covered with a thick layer of soot. I can't even see through the glass on the neck. The camera sucks at recording dark stuff, so I had to crank up the ISO to show you this. But inside this can here, it's completely filled up with soot. Okay, at this point I realized that I wouldn't be able to include this repair in the Aptiva video. So now it's actually the next week. It was suggested in the comment section that we might have a tiny crack in the flyback. And when I washed the board, some of the water may have found its way inside the flyback. I have washed many PCBs from CRT displays and never had this issue. It was also suggested that I should leave the display for a few days and see if it will dry up. So I'm going to indulge you, because it's been a week, so let's start by just turning it on and find out if that was our issue. Okay, let's turn the power on. I heard a relay and we've got high voltage. So let's turn that IBM on. And I heard some high voltage again, but we're getting nothing on the screen. So unfortunately that didn't fix the issue. I can hear some crackling noises from the display and the heater does not turn on. Well, since it's been a week I decided to do a quick test of the spare tube. And it's still working. So that's great. That will make the troubleshooting much easier. Okay, so the obvious thing to try here is to test the broken display with a known good board. Since I had a week to prepare, I have washed this board too. So at least the board is nice and clean. By the way, the reason why I don't just use that spare display is because it has seen so much use. The tube is probably very worn and the case is so brittle it kind of falls apart as I move it around on the bench. And this display here had a very reasonable amount of dust inside. So at least the tube is probably in great condition. Okay, everything has been reconnected. So we've got the spare board installed in the broken display. Okay, let's find out if the fault is on that main PCB. I'll turn the power on. Heard relay and high voltage. And the LED is flashing. Let's turn that IBM on. Okay, fingers crossed. Got some more high voltage. We've got an image. Awesome. I'm gonna have to do some minor adjustments here. Okay, this is looking pretty good. It's slightly too bright. No wonder the brightness was cranked up to 80%. So that tells us something about the other tube. So I'm gonna take it down to 50%. Contrast is cranked up to 79% too. So the other tube is probably really worn out. But on this tube, 50% looks perfect. These late displays are really easy to adjust compared to the older displays. Everything is done in this menu. We can adjust pretty much anything in here. Oh, I just noticed on my previous screen that I'm overexposing. Okay, I adjusted my camera. So this is roughly the image I get in real life here. So if I move in real close in the center of the display, I'm gonna say that image is superb. This display, by the way, is recognized by Windows as an IBM 6547. But apparently we're not quite done with this display yet. Before I put the lid back on, I had a look on the board and check out this cap here. That damn thing started to bulge while we were testing the board. So I guess now we know what happened to the other board. It probably has a dead cap. Now the problem with bad caps in CRT displays is that when they go, they can kill some other components too, like transistors. So I'm gonna leave this display off and order a set of caps. When they arrive, I will recap the other board first. If it starts working, we'll put it back in. And if not, we'll always have this pair board here. This is hard to see from this angle here. But this cap here was not bulging just a few moments ago. Well, needless to say, if you have a G74 display, now is probably a good time to order some caps. I'm not going to make a separate video with just a recap of this display, but I will include it in the next video with a matching IBM. It might actually be this IBM because I want to do some upgrades. This IBM only supports up to Pentium III 550, but I read somewhere that it can go much faster. Same thing with the RAM, it only supports 384 megs, but as you saw earlier, this machine has 768 megs already. I'm also considering a hack with the motherboard. If you're watching this in the future, I'll put a link to that video on the screen here. If you're watching this fresh, hit the bell icon below and set it to all to get a notification from YouTube when the next video is out. Meanwhile, check out this video. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up and a comment. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.